All right, everybody, welcome back. I'm going to be doing a video for Algebra 2. I'm going to be giving some extensive practice on our natural logs. So I'm going to go ahead and start off with a little overview of natural. So we have the natural E, which is the natural exponential function. The natural exponential function is Euler's number, right? So this looks like this, f of x. Sorry, let me get a new pen. F of x is equal to e to the x. Okay, so quick little overview is e to the x has this property. It is an exponential function, which means that e to the 0 is 1. So it is growing in this manner here. So looking at that, we're going to recognize that the domain for this function is x such that negative infinity to infinity. However, there is a horizontal asymptote at y equals 0, so its range means that the natural exponential function can only have positive output, so non-inclusive 0 to infinity, okay? Now let's look at the natural log. And the natural log is the inverse function of the exponential function, okay? And so this guy, we'll call it g of x just so that we see some distinction, is now ln of x, natural log of x, okay? And if we look at that, okay, we recognize that this function now, ln of 0 is 1, right? I mean, ln of 1 is 0, sorry. So let's look here. I'll cancel this out. So what's ln of 1? It's 0. So ln of 1 is 0. So now we have this function that behaves in this manner. So now there is a vertical asymptote here. So which means that this guy's domain is now limited to only positive inputs. So that means 0 to infinity. And its range is now unlimited to negative infinity to infinity. So another way that we can prove that they're inverse of each other, remember the domain of one becomes the range of the other and vice versa. But I want to make sure you recognize how these functions behave because we're going to go ahead and do some analysis on this. So a quick little review. We're going to expand, we're going to condense, and we're going to solve and verify. That's going to be the assignment for this week. So the first example I'm going to ask you to do is expand the following. And let's say I have ln of 8 to the 5th over 7 all to the 4th power. So I recognize that I got to distribute, right? Extribute this guy. Got to distribute that exponent because it goes both to the base 8 and base 7. So I'm going to rewrite that as 8 to the 5th to the 4th. Remember, when I raise it to another power, we parentiply. And then that's 7 to the 4th right there. Okay? So now I'm going to go ahead and say that's 8 to the 20th over 7 to the 4th. So now I'm really going to expand. Remember, diff tract is the rule we're going to use here. So I now have ln of 8 to the 20 minus ln of 7 to the 4th. And my last rule would be to make that power to coefficient rule, where my power now becomes a coefficient in the front. So my final answer is going to say 20 ln of 8, 20 ln of 8 minus 4 ln of 7. And that is my final answer. Okay, my next one, I'm going to ask you to now condense, which is backwards of this. So I'm going to condense. And let's say I have ln of 5 over 2 plus ln of 6 over 2 plus ln of 7 over 2. And so we recognize they all have a half coefficient on them. So really what I'm looking is half of ln of 5 plus ln of 6 plus ln of 7. So notice that I factored out that half that they all had. So now I'm going to condense this. Remember, multiplied is the rule I'm using. So I'm going to condense that to ln of 5 times 6 times 7, right there. 5 times 6 times 7, here's my calculator. See, 5 times 6 times 7 gives me 210. So I have 1/2 ln of 210. Sorry. Oscar, open the door, please. And then here we are. So now this, I'm going to use the rule again, power to coefficient, which means I have ln of 210, but it's to the half power. Now remember, half power is square root. Remember this rule. I'm going to give you the rule. The rule says x to the a over b is equal to this rule right here. So this means I now have the rational power rule used here. So if I have x to the 1/2, that means I have a square root of x to the 1. So that's the rule I'm using here. So this is going to give me a square root of ln of 210. So this is my condensing part right there. Cool. Now I will also ask you to approximate specific output values for given inputs. So if I ask you to approximate, let's say I have ln of 3.4. So what I'm asking for, when the input is 3.4, what is the output for this natural log function? So this is how I do it. And I'm going to use a calculator. So clear it, ln 3.4, close the parentheses, and then enter, and it's going to give me 1.22377. So approximation means my equal sign is no longer straight, it's an approximation, so they become squigglies. So I have 1.22377. So my final answer for ln of 3.4 is equal to, I'd always like to have this number here. So I'm going to ask you to give me your answer not to the tens, hundreds, but to the thousands. So this is going to be the number that I'm going to finalize at. Because the 7 is bigger than 5, then that my final answer, approximation again, 1.224. So that's going to be my answer, okay? And now we come into the solve and verify section. You must solve and also verify for this to happen. So the first thing I'm going to do is, let's say I have ln of negative 2x is equal to ln of 3x plus 10. So here we must recognize that I already have common bases on both sides. So when I have that situation like that, all I have to do is literally analyze the inputs. Given that I'm looking at two lateral log functions of the same base, all I have to do is equivalize, that's a new word I just made, the inputs. So I now have negative 2x is equal to 3x plus 10. Good old algebra will help me finish this. So subtract 3x to this side. I have negative 5x is equal to 10. And now I'm going to divide both sides by negative 5. So this gives me that x is equal to negative 2. Remember, though, that I'm asking you to also verify. You will not get full credit if you don't verify. It must be true. And the reason we verify is because these functions, my natural log function and my natural e function, have restrictions. So we must verify that the restrictions are valid. Now here, this input, if it was just x, it would not be valid, right? Because my natural log, if I look at my original here, my natural log does not have any negative inputs. But I do recognize that it does have some other coefficient here, which is going to probably make it true. We're going to check that out right now. So whenever I verify, I have ln of negative 2x. I always start with my original equation of 3x plus 10. And then I simplify and I substitute the given information that I have. So I have ln of negative 2 times negative 2. Wherever there is an x, I'm now substituting that negative 2 to see if it's valid. So this gives me ln of positive 4 now. Is that going to give me ln of negative 6 plus 10? So I have ln of 4 is equivalent to ln of 4. I've reached a true statement, which means that this answer is now valid. Okay? Let's do one more. So this is only when I recognize that I'm analyzing two functions of the same family, then all I have to do is make sure that the inputs are equivalent to make that statement true. So let's look at another one. Again, it's going to be a solve and verify. So my solve and verify is going to say ln of x plus 8 minus ln of 7 equals 3. So before I start this one, I need to make sure we recognize I started this lecture or this video indicating that the exponential function and the logarithm function are inverse of each other. So they act as inverse operations to one another. So that's exactly what we're going to do here. So I do want to make sure that if I have e to the ln of a, this is going to give me a. That's the rule I'm going to use. Or ln of e to the a is still going to give me a. Okay? So these are the essential rules that I'm going to be using to justify the equation here and its solving. So the very first thing I'm going to do is I'm going to condense this here. So I have ln x plus 8 minus ln of that. So that's going to give me some type of ratio because subtraction means subtract. So I have ln x plus 8 over 7. And let me just make that bigger, right? Is equal to 3. Okay. So I have one side, I have the natural log, and the one side I have a real number. So again, I'm going to use one of these rules. And the rule I'm going to use e. So I'm going to raise both sides by e. So I'm going to go e to the ln of x plus 8 over 7 is equivalent to e to the 3. So what did I do? I raised both sides to the e. Okay. So here, this is going to cancel, and I'm just going to be left with that input and the natural log right there. So it's going to just give me x plus 8 over 7 is equal to e to the 3. So now I'm going to use regular good old algebra to solve this, which means in order for me to isolate x, I need to get rid of this dividing 7. So I'm going to multiply both sides by 7, and that's going to cancel that. So I now have x plus 8 is equal to 7e to the 3rd, and I'm going to now subtract that 8. So I have x is equal to 7e to the 3rd minus 8. Now, as always, I need to verify this, most importantly, because I'm not sure if this input is going to be valid for a natural log, right? So let's check. So I have ln x plus 8 minus ln 7 has to equal 3. Okay, wherever there's an x, I'm now going to substitute whatever the x is. Everything else is going to stay as same. And I'm going to check, what is that? So I have 7e to the 3rd minus 8. Okay, so now let's see. Simplifying just this inside, I have ln 7e to the 3rd minus 8 plus 8 minus ln of 7 is equal to 3. So here, the negative 8 and 8 cancel. So I have ln 7 of e to the 3rd minus ln 7 equals 3. I'm going to expand this. This means I'm going to add. This is multiplying. So I have ln of 7 plus ln of e to the 3 minus ln of 7 is equal to 3. Okay. So remember, ln of anything is just going to give, these are going to cancel out. So I'm just left with that 3. So I have ln of 7 plus 3 minus ln of 7 equals 3. ln 7 minus ln 7, bam, bam, cancel. I'm left with 3 equals 3. That's a true statement, which means this right here is my solution. Okay? So remember, take notes. You'll also need to complete your assignment and submit via Google Classroom. Have a good week. I am available during office hours. You can also shoot me an email. If you have any questions, I'm here for you. Have a good day.